Hello, my name is Christopher Thomas Cruz Salguero. I'm a mechanical industrial engineering student, and right now I'm applying for the Technical English 4 Proficiency exam, and this is going to be my video project that I did. Okay, so let's get started. I chose the industrial engineering project, and that's why we're going to talk about the statistical process control charts. These charts are very useful tools for engineers all over the world, um, so let's get to know more about them. Okay, first of all, what are control charts? Well, control charts are graphs that we use to study how a certain process will change over time. Also, they show us the average and control limits of a distribution. This is very useful to notice patterns and to notice any defect or something not working properly on a process. So here we have an example of a control chart. Um, okay, we can see down below there's a time sequence like I said, these help us evaluate processes over time. So right here we have the time frame. We're going to place like years, like months, days, hours, minutes, whatever. This is our time sequence. Okay, then we have right here the average output. Here we can mark all the averages, the median, the mode, and the mean of the distribution. So right here is where most of the marks or where most of the measurements will be. Also, we have to set up control limits. Right here we have the upper control limit and the lower one. So if a mark goes like up here, that's bad. We don't want that. And if a mark goes under the lower control limit, that's bad also. We want all the marks to be in this place. That's how we interpret control charts. Okay, so what is the purpose of using a control chart? Well, like I said before, we use them to compare events, past events with current ones, so we can see if the process is improving or if it is deteriorating. Also, they help us to know if the process is under control or if it is unpredictable. So, for example, we have a bottle factory. We want to know if we are filling the bottles with the same amount of water every time, or if that quantity is varying a lot. So we want to know that, and we use control charts for that. Also, we use it to identify issues in a process flow. For example, if a machine is not working properly, or if an employee is not working as intended, uh, we can see all the marks on the time frame and on the sample values, and we can detect if there is any problem in the process. Also, they help us to improve over time. So we can look for ways to improve the process, to make things more efficient, and to make the process to be under control. Okay, so those are the main reasons why we want to use control charts. Okay, as you can see here, we have this control chart. Right here we have the lower control limit and the upper one. And this is like the average distribution. So if you see up here, we have this dot, and it goes upper on the upper control limit. It goes even far beyond. So this is bad. This means that there is a problem here with the sample value number 11, and we can go back and check out what is happening in this position in the number 11. Okay, you read control charts. Right here we have the elements of a control chart. As I said before, we have right here the time frame. Also, right here we have the values, the sample values, and you can see all the distribution values are right in the average, which is fine, and the control limits, the upper one and the lower one. Because all the data in this one is like very close together, this means the correlation is fine. This means that there are no problems because all the samples are under the conformity levels, and this means that we have a pretty consistent process going on, which is really good. Um, what are advantages of using control charts in the industry? Well, they help us to take corrective action to see if we can improve in some area, or we can like fix a machine, improve a machine, buy a better one, or hire more qualified employees. Also, they help us identify any special causes or problems in our process, like I said before. They help us know if the process is working as intended, because if it is, if the values are varying a lot, this means the process is not working fine. But as you can see in the chart that I showed in the previous slide, the process was working as intended. Also, they show which step of a process is responsible for defects. Okay, now I have here an example of a control variation, because all the data is in between the control limits, and they are very close together. This means that the variation is under control, the process is fine, everything is working as intended. Yeah. Okay, so on the other side here we have a non-control variation, which is what we don't want a process to be. This means that even though most of the sample marks are in the average and within a nice range from the median and the mode and the mean, we have these marks right here that go far beyond the control limits, and this is really bad. This means that the process is not to be trusted. Like for example with the bottles of water, this means that sometimes we're going to put too much water on the bottles, or sometimes the customer is going to open his bottle of water and notice that there's less water than what it said on the label. So these will lead to customers being unsatisfied with the product, or failures on the processes. So we really want to avoid that. And as we can see here on this mark, it corresponds to the number 11. So we can go and check that part of the process and see what's going on and fix it. Okay, so now we're going to review some types of control charts. The first ones are going to be continuous data. So first we have like the most common one is the X-bar and the X-bar range and the X-bar S charts. They are used to evaluate consistency of process averages by plotting the average of each subgroup. They help us notice if any discrepancies between the samples. Also, we have the individuals and moving range chart. They basically they are used to see how a process is going on over time. So this is the key word right here is the time. So this is how we improve over time, and we try to make things better every time. So that's why we use them to compare like past processes with recent ones and see if we are improving or if we are doing things wrong. Then we have discrete chart. It is going to be the P chart. This is used to, for example, here we don't care much about the measurements or the numbers. We just want to know if the sample is a pass or if it is a fail, a pass or a fail. So we don't care the numbers. We don't care about the numbers. Just if the process is okay and if the customer is going to be fine with the product or not. The discrete data processes. The P chart should be included on this slide, but didn't fit. So we have the C chart. Okay, this is the same as the P chart. These are very similar, but what happens here is that we do care about the numbers and what's going on in each step. Also, we have the U chart. It's the same one, but what happens here is that the number of samples of each sampling period may vary. So this one has a lot more variation. Also, the NP chart. This one we use it when we want to identify the total counts of defective units within a constant sampling size. So the U chart is for a varying sample size, and this one is for a constant one. That's the main difference between them. Okay, so with all these control charts, how do we select the one that works the best for us? Okay, so we have a flow diagram here, which we can use to select the better one. Okay, so First, it says, which control chart should I use? Are you using continuous data or discrete data? If we are using continuous data, like numbers like 13.421, that's continuous data, we need to look at the sample size. If it's 1, we use the XMR or the IMR chart. It's over time. If it is between 2 and 10, we use the X bar R chart. And if it is more than 10, we use the X bar S chart. Okay, so on the other side, we have the discrete data ones. Okay, so here we take a look at defects. If there are multiple defects per unit, so for example, a toy, we are looking if the right arm is placed properly, if the head is placed properly, if the unit is painted properly, we use one of these charts. If the sample size is constant, we use the C chart, and if the sample size is not constant, we use the U chart. Okay, so if there's only one defect per unit, we use either the NP chart if the sample size is constant, or the P chart if the sample size is not constant. Okay, so right now we're going to review the application of control charts that I made. Here we have the photo of Tortrix. I wanted to know how much product was inside each bag. So each bag says 27 grams of Tortrix on each bag. So I wanted to prove if we were really getting the 26 grams, or if we were getting more, or if we were getting less. So we are going to compare how much we're going to analyze and compare the amount of product inside Tortrix against the amount they claim they put in each bag. So let's take a look at the results. Okay, so I took 8 bags of Tortrix. I opened them. I weighted them. So here we have the ideal weight, which was 26 grams, because that was what the label said. Also, I set up the upper control limit. This is the upper control limit, and this is the lower control limit. The max is going to be 27 grams, and the lower control limit is going to be 25 grams. And here we have all the measurements I made. And as you can see, we had mostly success. We only have 2 fails, which is pretty decent. I mean, this one failed for 0.1 grams, and this one also. So it's not. It could be worse. It could be worse. Okay, so what I did next to be able to create the control charts with the data I had, I went online and I downloaded an Excel document so we can have all the formulas here. Right here, as you can see, we have the upper limit and the lower limit, which were 27 and 25. Right here, the control limits for the X-bar chart. We have the average or the ideal value, which was 26. We have the upper control and the lower control, 27 and 25 again. And right here, down below, we have the data table with all the samples and all the information we have. And we have like the convenience sample, because I didn't want to eat like 20 Tortrix. I only ate 8 of them to be able to have a convenience sample, like not too many values. But if I wanted to make the investigation more professional, for example, I will take like 50 bags of Tortrix at least, and some of them buy them at Walmart, some of them buy them in the store next door, some of them buy them in La Torre, for example. So we have all the samples. So let's see what happens here when we put all the values. We get the X-bar chart, which was the most indicated for this type of distribution. Right here you can see that here we have the control limits, and the only points going below the control limits were this one and this one that was right on the 25 mark. So what this means is that the process is under control, and that we are getting the exact quantity almost in each bag, and this is really good. Also with the X-bar, we have the X-bar range graph. This one just tells us the correlation between the samples, and if for example, if, as we can see here, the the marks are very close together, and that means the measurements we took before are okay. But for example, if here we have in the x bar r graph, we have points here, 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 and it goes like this, something like that, that makes the experiment not valid because it it like if the x bar r graph is like this, this means that the numbers on the x bar graph that we saw before, they don't matter. They are not valid for the experiment. So what we concluded with this is that we can trust our tart tricks because 7 out of 8 items showed a satisfactory result. The variability was consistent, the statistical control was consistent, and we have some occasional non-conformance, which means like when you open your tart tricks and you say, hey, I got too little torchics on this bag. This is the occasional one, but it's pretty rare according to the results. Also, some other conclusions about control charts is that they prove to be very powerful tools in every industry, not only for the industrial engineers, but for every engineering there is. Um, Also, we know that there is a control chart for each situation, for each sample size, for each type of variable. So we have plenty of options. Also, we know that control charts show data and patterns in a easy to interpret way. So they are really helpful for us. Okay, thank you for your attention. If you have any questions, you can find me at my email right here. And thank you very much.